So properties of exponents. Again, this is going to be a review of concepts you learned in pre-algebra. We're reviewing it because it's very important that you know these rules, these properties, before we start our unit on polynomials. It's also a good review that with the map test coming up, you'll be able to most likely apply these. Damaris, Isaac, and Anna, put your computers away, please. So, the main thing is, I guess, before we get into like the rules, that when in doubt, write it out. So, if you can't remember the specific rule, which is understandable, you can't remember exactly what the rule tells you, because if you do the rule wrong, you'll get the problem wrong, right? So if you can't remember the rule, when in doubt, write it out, which mathematically that's called expand. So when you're doing this, you can't remember what you're supposed to be doing. When in doubt, write it out. So let's show a quick example of what this means. So if you had the problem, 3x to the third times 2x squared times 4xy times 2y to the third. So if you look at this problem and you're like, I have no idea what to do, write it out, meaning expand it. So instead of 3x to the third, that's really 3x, x, x. 3x to the third. I expanded it. And instead of 2x squared, it's really 2x, x. And 4xy expanded is just 4xy. That's already expanded because there aren't any exponents in it. And 2y to the third is 2y, y, y. I expanded it. I took out all of the exponents and I wrote it in expanded form. Now, looking at this, I can rewrite it. I can unexpand it, correct?
Yeah.
So, 3 times 2 is 6, times 4 is 24, times 2 is 48. And then I look and x, 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 oops, x is x to the sixth. And then y, 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 y is y to the fourth. So when in doubt, write it out. Does anyone know the rule? Remember the shortcut? Because you don't have to do it this way. Does it work this way? Yes, but there's a shortcut. There's a property. There's a rule. Anyone remember it? Okay, so it's when powers, and remember the whole thing's called a power. When powers have the same base, what's the base?
Big number.
The big number, the bottom number. When powers have the same base, multiply the coefficient. What's the coefficient? Number in front of the variable. And add the exponents. Plural. When powers have the same base, multiply the coefficient and add the exponents. When powers have the same base, multiply the coefficient and add the exponents. So if I looked back to my original problem, my coefficients were 3, 2, 4, 2. 3 times 2 is 6, times 4 is 24, times 2 is 48. Multiply the coefficients, add the exponents. So x to the third, so 3 plus x squared plus 2. 3 plus 2 is 5, plus 1 is 6. And y to the first plus y to the third is y to the fourth. So there are two ways to do it. You can expand it and reorganize. When in doubt, write it out. Or if you remember this rule, you can use this rule and it saves you a little bit of time. When powers have the same base, right? I can't combine these two because they're not the same. I've got an x and a y. Those are different bases. But this is the same base as this, is the same base as this. So they can be added together. Try an example. Practice it on your own. You can decide which way you want to do it. Four a to the third b squared times 3a to the fourth b to the third c. 4a to the third b squared times 3a to the fourth b to the third c. You can either write it all out and then reorganize it, or you can use the rule. Who thinks they have it? I believe in you. Gavin. Okay, so 12, because he multiplied the coefficients. 4 times 3 is 12, right? Yeah. Then let's look for powers with the same base. So we have a to the third plus what? A to the fourth. 3 plus 4 is a to the seventh. What else goes together? B squared and b to the third makes what? B to the fifth. And then all by itself is C. What do you think the most common mistake is that people do? Instead of adding their coefficient, or their what are these called? Exponents. They accidentally multiply them. You know the one that's most common is 3 and 2. It's 3 plus 2. I know you think, no, it's 5. I 100% get it. But somehow 50-50 shot on whether or not you put down 5 or 6. It's just the way that it is. Okay, so let's, when in doubt, write it out again. Here's another example. 3x to the 4th to the 5th. I don't know what to do with this. I've never had a double exponent. Up here, they're all separated, right? So when in doubt, write it out. What does this mean? It means 3x to the 4th times 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 3x to the 4th. Right? It means 3x to the 4th 5 times. You could even go a step further and rewrite this all out, right? 3 x x x x 3 x x x x 3 x x x, right? You can do that. But I know a rule now. Correct? Now this problem has turned into powers that have the same base. Correct? So since they have the same base, I'm going to multiply the coefficient and add the exponents. So that means 3 times 3 times 3. Uh-oh, I'm running out of time. Things that I know. 3 times 3 is 9, times 3 is 27, times 3 is...
80 something.
Yes, something less than 100. Times 3. Someone needs a calculator. 243.
You say it was less than 100, Miss Thornton?
No, this times.
Oh.
Time. I was over here at less than 100. And then 4 plus 4 is plus 4 plus 4 plus 4. So 243 x to the 20th. But I don't have to go through all of that work. I don't have to expand it. When in doubt, write it out and then use a rule. There's another rule for this, and this rule is when powers have a power, when powers have a power, you distribute the exponent. When powers have a power, you distribute the exponent. So what does that mean? It means this exponent of 5 goes to the 3. So what's 3 to the 5th power? 243. This 5 also goes to the 4. What do you think you do with 5 and 4?
Multiply.
You multiply the exponents. So you distribute that exponent. And you multiply the two exponents together. So it's 3 to the 5th. Well, what's 3 to the 5th? 243. And x to the 4th to the 5th, you multiply those. 4 times 5 is 20. So let's try an example. Let's do 4x to the third squared times 3y to the fourth. You could write it out. If this rule doesn't make sense to you, 100% you could write it out. Or you can use this rule, which is distribute the power. So what's 4, my coefficient, squared? 16. And x to the third squared, I'm going to multiply x to the sixth. Then I'm going to do the next part, which is 4 to the third. I lied. 3 to the fourth.
Or 81. I think that's right. Yeah, that's right. It's right here.
Okay. And then this goes to the 1 exponent. Good. So it's y to the fourth. I'm still not done with this problem, though. Because now this problem is this problem. What can you do? Multiply the coefficients. 16 times 81, it's big.
16.
1,296. Can you combine? Should I add these? No, because they're different bases. And there's our answer.
Is that in alphabetical order?
It is in alphabetical order. All right, so we have 2 more rules.
What?
Yep.
Time for you to go to wash.
Okay, so next example. X to the sixth, y to the fourth, z to the nothing, z to the first. Let's give that a coefficient. Let's do 10. 10x to the sixth, y to the fourth, z, over 4x to the fourth, y to the 10th, z to the third. Yeah, this will be on your homework.
What do you like? Write them out and
No, you did not. So when in doubt, write it out. So we have 10, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, and 1. When in doubt, write it out. Over 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. So when in doubt, write it out. And if you write it out, you can then do some canceling. Because if you look, x divided by x cancels out.
Oh, I remember this. Oh my God. Cancels
And x divided by x cancels out because they're, I mean, right? You've got 1 and you're dividing by the same thing. It is 1. It cancels out. And x divided by x cancels out.
Yes, my dude.
And x divided by x cancels out. Anything else cancel out? Y divided by y cancels out. Anything else? Oh yeah, y divided by y cancels out. Y divided by y cancels out.
More.
Y divided by y cancels out. Anything else? Z divided by z cancels out. I can't do 10 divided by 4, but can you simplify 10 divided by 4? Which is 5 over 2. And what's left in my numerator? X squared. And what's left in my denominator? Y to the 6th and z squared. So, when powers divided by powers have the same base. When a power divided by a power, or when powers, plural, divided by powers have the same base, what do? Like right here, x to the 6th divided by x to the 4th. What happened? What was my answer? I got 2. You subtract the exponents. But there's a disclaimer. Because, according to that rule, y to the 4th divided by y to the 10th, 4 minus 10, oh, let's put in there, it's going to be numerator minus denominator, always. Top minus bottom, numerator minus denominator. 4 minus 10 is what? -6, but I don't have a -6. What do I have? I have a +6. So, negative exponents, what? Go to the denominator. And I'm going to put a little star next to it, because that's not really true. Because what if there's a negative exponent in the denominator? It's going to go to the numerator. Most of the time, though, negative exponents go to the denominator. Little star. Or move to the numerator. Does that make sense why we put that little star there? Because it's not always true that it's going to go to the denominator. In this example, in 85% of these problems, yes, it goes to the denominator. But if they give you a problem where it's already in the denominator and it's negative, you have to move it to the numerator. What do you do with your coefficients? One last thing. Not necessarily divide, because dividing sometimes results in decimals, which I guess are okay, but whatever. Simplify. If it's, you know, 10 divided by 2, yeah, you can do 10 divided by 2 and get 5. Where do you think 5 would go, in the numerator or the denominator? Numerator. Whole numbers go in the numerator. This flash back to you